Welcome to CAI1000 Introduction to AI. This is a bit of a survey course, but we're also going to dive a little deeper into some of the models because I want you to get an intuitive understanding of what these models are doing. That'll help you understand better the outputs that you're getting from AI tools and then how you can use those in your own academic career, in your professional career. So just a quick word about me. I'm a software engineer by trade. I've had just about every role you can imagine in the software development lifecycle. It is my passion. It's what I've always been interested in, and I started teaching computer science last year. So when most people think about AI these days, they're thinking about a subfield of AI called generative AI, which really, after ChatGPT was first launched publicly in November of 2022, this is what most people are thinking about. So image generation is a part of that. And so I want to start out by showing you this work of art here. So do you think this was created by a human being or was this created by an AI? This is a very nice work of art. I mean, I certainly enjoy it. So you're forming your opinion. Let me show you one other piece of artwork and then see if that changes your mind. This right here happens to be my favorite work of art. This is Vincent van Gogh, Cafe Terrace at Night. So Vincent van Gogh, probably most of you recognize the name. And this is, I think, an amazing work of art. Now, the first one that I showed you, that was created by an AI. And you can see the similarities. So an AI could have learned some of the patterns from Van Gogh's style, certainly the theme and the basic idea of being a cafe on a nice evening. So this is a good example, good representative example of what generative AI can do. It can take in data, learn from it. It's called training. Be trained on these input examples and then generate derivative works. In this case, it's images. Obviously, you have text. You now have music generation. AI music generated capabilities have come a long way and actually are quite good, and video as well. So there's a lot of really interesting things going on. But keep in mind that these models have learned from existing data. Well, most of it is real world data. Sometimes now it's synthetic or generated, and then they're learning and applying those patterns. Okay, we've used the term artificial intelligence already, and we're going to define that in a second. A few other terms that you may have already heard: machine learning. We're going to spend an entire module focused, actually 2 modules focused on machine learning, because that is really the backbone of all of these capabilities, and that is learning from data, where we don't explicitly tell the computer what to do. We simply give it a bunch of data and let it figure out its own understanding of those patterns. Now, deep learning is a subfield of that, and this refers to neural networks. This is a type of machine learning model that we're going to study. And deep learning would be a neural network with many hidden layers, so that essentially the network is going to take in some data or information, which you could think of, that could be a prompt, as in an LLM, or it could be a bunch of specific data about some problem that we're trying to predict or classify. It's going to really go through a number of different transformations on that data until it comes up with an output answer. And so that is what deep learning is, and that is really what powers the success of a lot of AI tools like ChatGPT and these large language models that we'll be studying later on in this course. Now, let's back up. So if we're talking about artificial intelligence, what is intelligence to begin with? There's a nice paper that I've linked to in the course materials that summarizes or has a good collection of different definitions. The first one is a circular definition that doesn't really help us a lot. It's what is measured by intelligence tests. And it's difficult to get people to agree. So IQ tests are probably the most common standard that we have. And the same thing happens with AI models these days, is people come up with different benchmarks. And so we're trying to look for some standard or generalized ways to evaluate how quote unquote intelligent the different AI tools are. Part of the challenge is that as these new benchmarks come out, that information becomes somewhat available to be fed into the training material. And then also engineers and teams that produce the models can kind of tailor it to succeed well at those type of problems, but not necessarily others. If you look, the dictionary that comes with Mac OS defines intelligence, the ability to acquire and apply knowledge and skills. And then you get some other, this next one is pretty interesting. It's a very general mental capability that includes in this list of different things, which to reason, plan, solve problems, think abstractly. These are all things we could probably agree, yeah, no, that sounds good. Now, one interesting thing that we're going to look at is the Turing test. So Alan Turing, back in the day, we're going to study this in a moment. he basically said, you know, it's too hard. We can't get everybody to agree on what intelligence is. So I'm just going to step back and look at the behavior. So if I can replace that question with another one, and we're going to look at the Turing test, which is if I can have a conversation and not know whether I'm talking with another person or a computer, then we can say, okay, then that system is intelligent. So that was an interesting way to look at that problem. And interestingly enough, we've surpassed almost that at this point, which we'll look at in this course. Here is a diagram that shows you the Turing test. You're having, through a chat interface, this is generally how it was defined, that I'm talking with two different people or entities, and one of them is a person, the other is a computer, and can I tell which is which? So again, this is more of, rather than a mechanistic, like understanding the internals of how something works, whether it is acting intelligently or not, this is a behavioral approach. So from the outside, my interactions with this entity, does it appear to be intelligent or not? And a good measure of that was, if I can't distinguish it from a person, then that seems like it's pretty good, pretty intelligent. Nowadays, large language models can generate text that is very human-like. In fact, it's almost really difficult to decipher or discern whether a generated piece of text came from a person or an AI. There are tools that attempt to do it, and there are giveaways, but it is a very difficult technical problem that will only get more difficult as these models get better. So we don't really talk about, the Turing test was a milestone in AI for a long time. If we can do this, we've accomplished, we've created an intelligent system. Now we've kind of reached that point, and people are looking beyond that to AGI, or artificial general intelligence, meaning not just language, but can a system generally solve different types of problems and perform different tasks. So we're going to dive into this a little bit more coming up. Now, when we're talking about intelligence, we're often talking about the ability to solve problems. And if you can create a general intelligence, you can solve problems that you haven't specifically seen before, but you can use skills and patterns you've already learned to do that. This question here is a typical kind of IQ test of type of question. It is pattern recognition and then applying that to solve the problem. So which of these figures belongs where the question mark is? So if we look at this, the different images here, we start in the upper right corner and we go down the first column. You can see those X's are both sliding down one spot. Okay, that looks like a pattern, so we would check to see, does that apply also across the board? If you look at the second column, it does, because those X's slide down. Now, in the third column, you've got them staggered. So the question is, they do slide down from the top right to the middle right side of that column. Okay, what happens next? Well, basically the ambiguous question here is this X in the bottom lower corner. Does it simply fall off the bottom, or does it wrap around to the top? So now we also need to use the process of elimination. If we look at our choices on the bottom, every one of the choices has two X's. So in that case, we can assume it probably wraps around. And so our choice that we would logically go with here would be this one in the lower left, right here, where the X wraps around to the top and this X on the right-hand side drops down to the bottom. So if you think about what we just did there, it was looking for patterns, testing out to see, does this pattern work? We also had to apply a second deductive reasoning step, which is saying, okay, well, it could be one or the other. The first option, only having one X left, that wasn't a choice. So, okay, that must not have been, we went through a number of different steps to do it. So those are all things that are involved in intelligence. So we want our AI systems to be able to exhibit these same types of problem solving capabilities. And I'm going to give you one last definition to consider. And I really like this definition because think about what we just did. We went through somewhat of a search process, meaning that we were given the question and there are many possible ways we could go to try to figure out what was that missing tile. There's any number of possible methodologies, approaches, formulas that could have been used. So given the information that we saw, given what we know, we started to try out different things. And so if one approach would not have worked, we would have backed up and started going down a different route. So this definition here is great. The ability to rapidly find an adequate, doesn't have to be perfect, but an adequate solution in what appears to be ahead of time an immense search space. So if you think about solutions to different problems, there's a multitude, thousands, sometimes millions of possible combinations of ways we could do things. So given that, it would take too much time to try out every one. So we have to be smart. We have to think about, okay, what are the best ways we can start to approach this, narrow it down. And this ends up being a lot of what machine learning and AI is about, as we see. The systems are learning from data, from their training, that what are the patterns that we should apply in order to get to what we believe is the right answer. This here is an interesting example. So this is a question that this has been a little while now, but I posed to ChatGPT 3.5, and then here you can see is my conversation where I asked ChatGPT 4. So this is even before the 4.0 model came out. And this is another type of IQ question where you've got this pattern of numbers. It's really an addition problem if you look at it. So you've got two numbers on the outside, and you take the sum of those numbers and you put that in parentheses in the middle, and you're trying to figure out what that missing number is. So what's interesting about this is in typical training corpora, you would not probably have seen an addition problem worked out this way. So there would have had to be some type of reasoning that was involved. In this case, ChatGPT 4 did get it right. ChatGPT 3.5 did not. And you're seeing that in more and more cases because the language models these days, they're adding more reasoning capabilities. And in fact, the recent OpenAI o3, o1, and o3 models and DeepSeek have used reinforcement learning, a technique we're going to talk about in this course, to better be able to do quote unquote reasoning, problem solving, and to some degree, this is our last definition of intelligence. It's in a very large space of possible solutions. Can we quickly or somewhat efficiently and intelligently get to a solution, find the right answer? And more AI models these days are able to do that, especially in the fields of mathematics, to some degree logic, and certainly computer science and coding. Why is that? In large part because those are easily verifiable domains. So AIs are very good at writing code, creating software. How is that? Because they can generate code and immediately test out, does that code compile or is it syntactically correct? And then it can also run the code and see, does it get an answer that I expect? Other areas where you're asking more subjective questions, so does this economic policy, will this be effective? Those, there's no necessarily one right answer. Different people have different opinions. And so those are kind of harder to verify, and you may agree with what the AI says for some of these types of questions. You may disagree, but it's not as cut and dry as some of these other cases. Okay, so like I mentioned, since November of 2022, there's been a lot of excitement around AI because of what ChatGPT started and now other AI models. So we're going to look at it. AI, the pursuit of artificial intelligence, has been around for a long time, and it often goes through these cycles of a new technical breakthrough is made, and everybody has very high expectations. They think it's going to be able to solve all of the problems, lead to artificial general intelligence, and it may or may not end up doing that, but people get these really high expectations. Then you end up seeing the flaws in that approach, or maybe it can slice and dice bread, but it can't do everything. And you get this trough of disillusionment. This is not just AI, this is the technical, any really hype cycle for any product or technology. The slope of enlightenment is where you realize, okay, you get into this mature state where I understand the pros and the cons, the strengths and weaknesses of this technology. And now organizations are able to incorporate that technology and really leverage the benefits. And you end up with this plateau of productivity. I'll let you decide where you think we are right now with generative AI. I would argue that we're certainly not at disillusionment, but we've seen a lot of investment from industry, and certainly in the technical industry, lots of companies are investing large amounts of money. That usually happens. This happened way back. We're going to study the first time that the foundations of neural networks were created. People thought that was going to solve all these problems, and of course they realized, well, we're not quite there yet. We've got a long way to go. So this is a very interesting time to be in AI, and I believe that there's really some incredible capabilities. And whether you can debate whether we're on a path to AGI, artificial general intelligence, or not, but the capabilities and these tools are going to be pervasive. And so in this course, I want you to get an appreciation of them and know how really two key things: know how to ask questions, what are the right questions to ask, and then how to evaluate those answers, because those are going to be key skills going forward. These tools are going to be available in your careers going forward, so you're going to want to know, you're going to want to be familiar and comfortable with them, and also know how to verify their outputs and decide, how do I incorporate that into the task at hand or what I'm doing. Okay, so we've been talking for a while now that AI has been around for quite a while. It actually, the term AI, 1956, you can go back to this original conference at Dartmouth, so we're talking 70 years ago now. And these four big names, they are all major contributors in this field, but they got together over a summer and really studied AI, and that's where this term came about. And so following that, there was a lot of optimism, and you see this hype cycle kind of repeat where a new milestone is achieved, lots of investment, and then it kind of cools off, and then that cycle starts again. At one point, we thought that, okay, well, if an AI can beat a human at chess, then that will be intelligence. We'll look at that in a second. And then we got into machine learning and deep learning, which really took over and kind of led us to where we are right now. This chart here has some big milestones, which you can look and see what are some of the things. So Alan Turing, we already talked about, that was back in the 50s. And there's some other pretty interesting things. This covers up until about 2000. So something that we're going to look at right now is in 1997, Deep Blue, the IBM supercomputer, beat Garry Kasparov, who was the world champion in chess at the time. That was a huge milestone. And so here is a picture from the Wikipedia page that discusses this. And in fact, it was the first time that Deep Blue won. It was actually a very close match, or series, I guess you could say, where it barely edged out 3.5 games to 2.5 games. Okay, so let's look at Deep Blue's quote-unquote intelligence. How did it do this? Well, it had a mini-max algorithm, and so that is an algorithm where it would evaluate the board state and rate it favorably toward one side or the other. And the min-max part comes from when it's your move, you want to maximize the potential. Then when it's your opponent's move, you want to minimize it, right? You don't want them to do well. And it would look ahead 14 to 20 moves. So a very deep tree. And this is our search problem to some degree, where it's trying out different moves and seeing what leads to the more advantageous board state for me. Now, how do we know whether a board is good or not? So that's an evaluation function. And this is a problem, or a challenge, I should say, in both machine learning and AI that will come up over and over again, which is, how do we know if our model is headed in the right direction? Are we making the right predictions? Are we coming up with the right answers? And so usually in reinforcement learning, it's called a reward function or a value function. Evaluation, when we train models, we want to know what our error rate is, how far are we from the correct answer. So in this case, this is an interesting problem, because given any board state, how do you know if it's good or bad? There's different ways to do that. But they had a very sophisticated algorithm that considered a number of factors, some of which are considered here. Is the king in a safe place? How many pawns are left on the board? What's the structure? All of those things. And then in addition to all of this, chess has kind of classic opening sequences as well as endgame. And so it had a database of those moves as well that it could access and pull from. So all of these things together. Now, does that represent true intelligence or not? Well, certainly it represents, or it implemented, a very good chess playing program. And it'd be very difficult to beat this program in a game of chess. Later on, we also saw that the game of Go, which has even more possibilities, as you can see. In this search space, in this box right here, you can see how many legal positions there are in the game of chess. So the game of Go has 10 to the, 170 positions. That is more than there are observable atoms in the universe. So even if we had a computer that used every atom available to us, we wouldn't be able to compute those different possibilities. This is that massive search space that I was talking about, where can I intelligently navigate that and look for a good solution. And so you can see that there's brute force will not do it. That's where intelligence comes in. So in this case, this is an example of a more narrow AI. So a narrow AI system would be one that does a single task really, really well. In this case, Deep Blue played chess really well. AlphaGo played the game of Go really, really well. But could it summarize a piece of text for you like ChatGPT can? No. Can it do these other things? Can it make a prediction on whether a given email is spam or not? No. general or strong AI would be an AI system that can generally solve lots of different problems. Now, this is one of the reasons why LLMs are getting so much attention, because they can do a number of different things. They can answer, we'll say, factual questions, although they can hallucinate, but they can answer questions, so knowledge retrieval, they can summarize text, they can generate new pieces of text. So a lot of different use cases, and you're seeing some generalization in their ability. Also, we talked about reasoning and the ability to solve different problems. So that is one of the things that truly makes generative AI exciting. So briefly, just to reiterate, when would you use machine learning and when would you just write a piece of software? So this is kind of the difference. If you have a problem that you could spell out, you could write down what are the specific rules that I need to follow or the logic. There's not a ton of different permutations or combinations. I don't need an extremely flexible system. So just write the software to do it. Machine learning is if it'd be difficult to, and maybe we don't even fully understand all of the patterns. There's a lot of data available that I can learn from, a lot of complexity, perhaps hidden patterns or relationships that aren't at the surface level necessarily clear. Those are great problems to let machine learning handle for you. And as you can see in this diagram here, machine learning, a foundation of AI, is giving it data and using what are essentially mathematical models, letting them find the pattern. So we're not explicitly telling these programs what to do. They are backing into the solution given the data. And that also leads to a downside, which is we can't always explain exactly why these systems give a particular output or prediction or classification. So there is also a large field called explainable AI that seeks to understand how did these models arrive at different answers. And that also gets to concerns about safety and ethics and bias, and making sure that if our training data was biased in some way, are we going to get biased outputs? So a lot of active research in that area we'll touch on in this course as well. Briefly, we're going to get into machine learning in one of our next videos, but the types of learning that we're going to look at are supervised, unsupervised, and reinforcement learning. Supervised, that means I have data and I have not only just the question, but also the answer. I have the input sample and what the output should be. Now, this is great because I can train the model based on that. It also can be challenging because I need to get that data. Not only do you need to get the data, it needs to be tagged and verified that it's accurate. And sometimes I either need to procure this data if I don't already have it, or I need to generate it, or I need to get humans to review it and tag it. So think about product reviews on an e-commerce website. Is that a good review or a bad review? Maybe initially you need people to go and categorize each of these reviews and label them as positive or negative, whatever the use case might be. So it's a very effective technique, and we're going to look at it quite a bit. Getting data is what fuels all of this, and so sometimes that can be the challenge. Now, unsupervised learning, you can just give it the raw, unfiltered data, and it can do some interesting things like segment them into different clusters. So fraud detection, detect anomalies. This data looks to be kind of out of the norm from what the other data looks like. So you can do some interesting things with that. And then reinforcement learning is kind of a special category where you're letting the agent or the system kind of explore a search space and then get feedback and have it learn along the way. So we'll dig into that as well. We'll talk about how that applies to language models. Okay, I think I'm going to stop here. That's probably a good enough kind of introduction to the field of AI and what we're going to kind of tackle in this course. So look for upcoming videos. We're going to talk about data, learning from data, and then kind of go from there into machine learning models, and then how we build AI capabilities on top of that. So I'll see you in the next video.